Welcome friends. Today we will see what is linear transformation and how to use this one and how to know a transformation is linear or not through an example. So let us start with the concept of function or mapping. So if we have two non-empty set A and B, then we write f is a function from A to B if each element of A, that means each element of A has unique image in B. Now the A is called domain. Here A is domain, B is target or target set. It is domain set A, target set B. Now this f is known as function or mapping. F is function or mapping. Now here we can see that if in place of A and B we have vector spaces, then what we call? So that time we can write A is a vector space from vector space V to W, where both the vector space are defined in a same field, that is K. We can write it as let two vectors space S B and W are defined on same field K, then this transformation or this function T from V to W is called transformation. Then T is called transformations. So just the same idea with vector space. Now if so T V to V and V to W is called transformation. Then if T is from same vector space to same vector space, that means T from V to V, then it is called operator. T is from V to field K, then it is called functional. Now we will see with the same definition transformation when it is called linear transformations. Means what are the properties a transformation obeys, then it is called linear transformation. So the transformation T defined over vector space V to W, then it is called linear transformation if it satisfies two properties. What are the two properties? First property is that for every vectors V and U belongs to V, we have this T of U plus V equal to T of U plus T of V. Now what is the second property? So for any scalar K, T of K V equal to K into TV. If these two properties will be satisfied by this transformation, then that is called linear transformation. Similarly, if T is from V to V and it satisfies these two properties, then that is called linear operator, and so on. We can write. Now we will see that means how to check linear transformation. means a transformation is given, is it linear or not linear? How to know? We will take one example, then we will find that whether it is linear transformation or not. So we will define T from R2 to R such that T of U equal to T So we will take one example and we will see that the transformation is linear or not. So first problem we will see, the first problem is defined like this. T is a transformation from R2 to R such that T of x comma y is defined as x plus y. So we have this transformation and we have to check that whether T is linear transformation or not. So how to check? So first property, so we have to check first property, that is T of u plus b equal to T of u plus T of b. So what we will take? We will take two vectors, u belongs to R2 and b belongs to R2, where u is nothing but u1, u2 two odd component vector, v is v1, v2 two component vector, and we have to show that T of u plus v equal to T of u plus T of v. So how to do? So we will take first T of u plus v. So T of u plus v, it will be what? T of u is u1, u2 this plus v1, v2 this one. So this will be what? T of u1 plus v1 comma u2 plus v2. Now what is the transformation? Says T of xy goes to this x plus y. So what is the value here? Then it will be u1 plus v1 plus u2 plus v2. Okay, this one. So LHS of this. Now we will do RHS. So RHS what? T of u plus T of v. Now T of u is what? T of u1 comma u2 plus T of v1 comma v2. Now if we add this, then what will happen? First we have to see this one. The transformation of this is what? u1 plus u2 plus this one is v1 plus v2. So the same thing we'll get here. So u1 plus u2 plus v1 plus v2. So both the values are same. That means first property satisfied. That means T of u plus v equal to T of u plus T of v. So it is satisfied. Now we have to see the second property. What is the second property? For any scalar, we have to take for any arbitrary scalar k, we have to show that T of kv equal to k into T of v. So first we will do the LHS part. So LHS part is T of kv. So it is T of k times v1 v2. So now what will happen? It will be T of kv1 comma kv2. Now what is T of kv1 plus kv2? It will be kv1 plus kv2. This is equal to, I can write it as k into v1 plus v2. So what is this? This is nothing but k into v1 plus v2 is what? Tv. Okay. That means this second property also satisfied. So we can say that T is linear or T is a linear transformation.